Hello and welcome to Physics Teacher. This tutorial is for a grade 11 university math course in Ontario called the Functions course. And specifically this video, I'm going to summarize all you need to know about quadratics. So let's get started. So we're going to start with this quadratic equation, and we're going to solve it using 4 different methods: completing the square, factoring, using the quadratic formula, and I'll show you how to use a graphing calculator as well to solve this. So the first thing we can do is notice that every term is even, so divide every term by 2. If it's equal to y and not 0, you can factor out every term by 2. So if we divide every term by 2, we are left with x squared minus 6x minus 7 equal 0. Okay, let's start with how we're going to complete the square. To complete the square, we're going to take this middle coefficient here, 6, divide by 2. So 6, I'll just do this on the side, 6 divided by 2 is 3. And then we're going to take that 3 and square it, and we get 9. Then what we're going to do is, right after that 6x, we're going to add 9 and subtract 9. And then don't forget we still have this negative 7 here. Now look at this trinomial right here. That is a perfect square. Or put another way, what number multiplied by itself gives you positive 9 and added to itself gives you negative 6? And that number is negative 3. So this simplifies to x minus 3 squared. And then this simplifies to negative 16. So that's how you would complete the square. So now we can solve this. So bring the 16 over. So we have x minus 3 squared equals positive 16. And if we square root both sides, we get x minus 3 is equal to plus or minus 4. So this gives us two solutions. X minus 3 equals positive 4. Or x minus 3 equals negative 4. So we can solve for each. For this one, x will be 7. And again, if we add 3 to both sides here, we get negative 1. So those are our two solutions, completing the square. Alright, so completing the square was a great way to solve this quadratic equation. Or if you have a quadratic function, it's a great way to turn this standard form into vertex form. But now we're going to another skill called factoring. Factoring is another great way to solve it. Or again, if it's a function, meaning it's equal to y, it's a great way to turn it into factored form, or sometimes called intercept form. Factoring, in this case, we have a simple trinomial because our a coefficient here is just 1. We need to figure out two numbers that multiply to give negative 7 and add to give negative 6. 7's a prime, so there's not many options we have here. But we could play with that negative. So you can either have negative 7 and positive 1. Those both multiply to give negative 7. Or you can have positive 7 and negative 1. But which two numbers add to give negative 6? It would be these two, not these two. These add to give positive 6. So we are left with x minus 7 and x plus 1. So now solving this one, we have two solutions. We have x minus 7 equals 0, or x plus 1 can also equal 0. So just as before, x can equal 7, or x can equal negative 1. All right, next we're going to use the quadratic formula. Now you can use the quadratic formula for this equation or for this one. It's easier to use for the second one, so always look to see if you can factor out or divide every term by a certain number first. And 2 is a great one to look for if everything's even. So our quadratic formula, if this is our a coefficient, plus that would be our b coefficient, and that's our c coefficient, our quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So if we apply that to this case, okay, we have minus b. b is negative 6 plus or minus the square root of b squared, so negative 6 squared, minus 4. A is just 1, and c is negative 7. All divided by 2 times a, which is just 1. Okay, so we can simplify a bit. Double negative gives us a positive. And if we figure out what's inside of that square root, which we call our discriminant, we get 64. And that's all divided by 2. All right, so let me continue. I've run out of room, so I'll just continue over here. So this is going to give us two solutions. Okay, the square root of 64 is just 8. So we have x equals 6 plus or minus 8 divided by 2. Okay, and the 2 we can apply to both the 6 and the 8 because that's nice. So that is 3 plus or minus 4. So x is going to equal 3 plus 4 is 7, or 3 minus 4 is negative 1. All right, so we're going to start by graphing our function. Now we can kind of see that it does look like our x-intercepts are minus 1 and 7, but let's make sure. So we're going to go to Menu, and then Analyze Graph. We're going to look at the zeros. Now I'm going to scroll over and click a range of where there's a 0. Okay, and so minus 1 and 0. So that first point is minus 1. We can do the same thing to find the second point. And it is 7. So we have minus 1 and 7. Those are our solutions. For this next question, we're going to find the equation of the quadratic function with the zeros 2 and negative 3 and contains the point 0,3. Now, since we're given the zeros, it's easiest to start this question off using intercept form or factored form. If we were given the vertex, we could start with vertex form. So if you remember, factored form looks like this. So our function is a times x minus r times x minus s, where r and s are the x-intercept or the zeros. So 1, 0 is 2, so let's have r equal to 2. So it would be a times x minus r is 2. And the other one would be negative 3. Now this is going to have a negative, so if s is negative and we're subtracting a negative, that's a double negative, so that's going to be x plus 3. Now, we still haven't figured out what this stretch or compress factor a is. So to figure out what that is, we're going to use this point. Remember, our coordinates are x, y. So for f of 0, the solution is going to be 3. And we can write that as a times, so x will be 0, minus 2 times 0 plus 3. So now we can solve for a. So this is negative 2 times positive 3, which is negative 6, and that equals 3. So divide both sides by negative 6, and we get a equal 3 divided by negative 6 is negative 1/2. Therefore, our function f at x is equal to negative 1/2 x minus 2 and x plus 3. Now, if you wanted to convert that to standard form, you can just expand that factored form. Then if you wanted vertex form, you can then complete the square of that standard form. Now we can check our function on our graphing calculator. So let's type in our function. Now here we can see that the zeros are 2 and -3, and we could do what we learned before to check that. But let's see if the point 0.03 actually exists on this graph. So we're going to go to Menu. We're going to Trace and do a graph trace. So immediately it started at the point we wanted, which is the y-intercept 0 and 3. So that works, but you can also move along the graph to confirm other points as well. And it will stop on our intercepts here. So we have 2, we have the point 0.03, and -3 and 0. And notice it will also stop at our maximum if we wanted to know that. So for our last question here, we're going to determine the coordinates of the points where this line intersects this quadratic function. Now it might intersect in 1 point, it might intersect in 2 points, or it might not intersect at all. But if it does intersect, those intersection points are going to have the same y coordinate. And since both equations are y equals and y equals, we can eliminate y by simply equating these two functions. And that's going to give us, so 0.24x plus 7.2 will equal minus 0.48x squared plus 4.8x. Now we're going to put this in the standard form. So bring everything to one side and set it equal to 0. So we will have 0.48x squared. So I'm just bringing this term to the other side of the equation. Plus 0.24x. And then I'll bring this term to the other side. So minus 4.8x. And then don't forget our last term here, plus 7.2 is equal to 0. Now I can simplify by adding like terms. So 0.48x squared minus 4.56x plus 7.2 equals 0. Now at this point where a lot of students like to go is they like to use the quadratic formula. And you can do that as we showed in our first example. But what we can also do is divide every term by 0.24. It's actually quite interesting how this worked out perfectly, because then it gives us 2x squared minus 19x plus 30 is equal to 0. Now that's not a simple trinomial, it's more of a complex trinomial because our a coefficient is 2 instead of 1. All right, so to factor this, we can factor it by grouping then. And so let's take our a and c coefficient and multiply them. So 2 times 30 gives us 60. And then our b coefficient is minus 19. So b coefficient is minus 19. So what we need then are two numbers that multiply to give 60 and add to give minus 19. So you can think about it, try different combinations, but what works is minus 15 and minus 4. So the double negative when multiplying gives us a positive, and when we multiply them we get positive 60, and we add them we get negative 19. So what I'm going to do then is split up this negative 19x into a minus 4x and a minus 15x. Now this is where the grouping comes in. So I'm going to put in brackets here, and we can group that, pull out a common factor, so we have 2x. So if we pull out a 2x, we are left with x minus 2. Right? And then we want that same factor, x minus 2, over here. And to do that, we are simply pulling out a negative 15. And that all equals 0. And then we factor out our common x minus 2 factor. And I've run out of room, so I'll write over here. So we pull out x minus 2. And we are left with that 2x minus 15 equals 0. So let me free up some space here. All right, so this is what we're left with. So we have two solutions here. We have x minus 2 equals 0 and 2x minus 15, which equals 0. And so x can either be 2, or, solving for this one, divide both sides by 2, x can also be 15 over 2, which is 7.5. Those are our two solutions. But then, of course, we don't just need the x-coordinates, we need the y-coordinates as well. So we can plug each of these x-coordinates into our equation and solve for y. Now, it doesn't matter which equation we use, but I think the linear equation will be less work. So let's start with the first one. So we'll use x equals 2. So to figure out what the y is, we do y equals 0.24 times 2 plus 7.2. And that gives us 7.68. So our first solution is 2 and 7.68. And then if we do the same for 7.5, we get y equals 0.24 times 7.5 plus 7.2. We get 9. So our second solution is 7.5 and 9. Now let's see how to do that on a graphing calculator. Now we can also find this intersection point on our graphing calculator. So let's start by entering our functions. And then we hit the down arrow so we can add another function. Now I can't see any intersection points, so let's go to Menu. And we're going to go to Window and Zoom. And I'm going to zoom into quadrant 1, because that's where this one appears to be. There we go. That's much better. So we clearly have two intersection points. Now we're going to go to Menu. We're going to go to Geometry and Points and Lines. And I'm going to select intersection points. And now we can select this graph and this graph. And when we do that, we get our two intersection points, 2 and 7.68 and 7.5 and 9.